Hey guys, so we're going to talk about solving a system by graphing. A system of linear equations is basically just a set of two or more equations in the same variables, and the solution is the ordered pair where they meet on the graph. So if you guys want, I will pause that really quick and I will write that down so that way you have some definitions. Okay, so I added that definition for you, so if you would like to, I would suggest that you pause the video, write that down, just so you kind of have an idea of what a system means and what it's going to look like when you graph it. So I'm going to give you two linear equations, and I want you to write them down, and I want you to try to think about what steps you would take to start graphing them and see where you can find the solution. So your first one is going to be y equals 2x plus 5, and I'm going to do the next one in a different color. And then this one is going to be y equals negative 4x minus 1. Okay, so I want you to pause the video really quick and think, what would my first step be? What am I going to do? Obviously, I need to graph them, and I need to figure out where they intersect. So how can I start that? Okay, so hopefully you thought about it, and really step one is graph each equation in the same coordinate plane. Now, what that means is you are using one coordinate plane, and you're going to graph both of these equations. So I'm going to go to a new page, and I will rewrite my equations for you guys. So the first one was y equals 2x plus 5, and then the second one was y equals negative 4x minus 1. Okay? So some reminders for graphing is that you want to start at your y-intercept, and then you use your slope for your rise over your run. So I'm going to do this first one first. So it says y equals 2x plus 5, so I start at 5. 1, 2, 3, 4, 5. Okay, and then my slope says rise 2, run 1. So that means I'm going to rise 1, 2, run 1, rise 1, 2, run 1, and then I'm going to go down the other way just to kind of finish up my line. So I do not have a ruler, so my line is not going to be the straightest, which is why I drew a bunch of my the points on my line so that I could actually see where they are. Now I'm going to graph my second one. So this one says I start at negative 1. So I start all the way down at negative 1. And my slope is down 4 over 1. So down 1, 2, 3, 4 over 1. Well, if I keep going this way, I'm not going to see where they meet. So instead of going down and right, I'm going to go up and left. And you guys can actually see right here is where they intersect. So really quick, I want you guys to write down what you think that ordered pair is. Hopefully you saw that they intersect at negative 1, 3. Okay? So that is the solution. So one way to check that is to substitute that in, and I want you guys to do that. So again, I'm just going to go to a new page, and we had our equations. So we had y equals 2x plus 5, and then we had y equals negative 4x minus 1. Okay, and then we said our solution was negative 1, 3. Okay, so negative 1, 3. So what that means is negative 1 is the x, 3 is the y. You're going to plug that into your problems, and then you're going to check them and make sure that they work. So I really like using different colors for this just because it kind of helps my brain. So y is 3. And then x is negative 1. And that is on both of these problems. And then what you're going to do is you're just going to bring down the rest of your problem because all you were doing was substituting it in and solve. So do that right now and make sure that it works for both of the equations. All right, so this one, 3 equals, well, 2 times negative 1 is negative 2. Bring down your 5 plus 5. 3 equals negative 2 plus 5 is 3, so 3 equals 3 is correct. on this side, you have 3 equals negative 4 times negative 1 is positive 4, and then 4 minus 1 is 3, so 3 equals 3. It works. So guys, that is it. That is how you solve a system by graphing. Super easy. Go back and rewind it. Practice it if you need to. I'm actually going to give you guys a practice problem right now. So here's your problem. You have y equals negative 4x minus 7. And then your other problem is x plus y equals 2. So I want you guys to pause the video, see what you can do, go back and look at those steps if you need to. The biggest thing I'm going to suggest is you look at your second problem or linear equation, because it is not in slope-intercept form, it is in standard form. So you might need to solve the equation to be able to graph it. All right, hopefully you guys realize that like when I leave extra space, it's because I'm assuming you're going to pause the video, making sure you're working, you know, that kind of thing. So this one, you need to actually move it. So x plus y equals 2. You need to isolate y. So that means we need to subtract x on both sides. So this problem is actually y equals negative x plus 2. So now that you have your two equations, you can actually graph them. So this first one says it's negative 4x minus 7. That means you start at negative 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I start at negative 7. My slope says I go down 4, right 1. I really don't have room to go down 4, right 1. So I'm going to go opposite. So I'm going to go up 4. 1, 2, 3, 4. Left 1. Left 1. 1, 2, 3, 4. Left 1. Okay. So hopefully that works. Again, sorry, I don't have a ruler. My lines are not perfect right now. And this next one says I start at positive 2. And my slope is negative x, which, guys, there's just an invisible 1 there, and you put it over 1. So it's down 1, over 1, down 1, over 1. So again, I'm not going to meet it this way. So I'm going to go opposite. Up 1 left, up 1 left, up 1 left. And you're going to see right there, there's my point of intersection. So that point is 1, 2, 3, negative 3, up 1, 2, 3, 4, 5. So the same thing, if that is your solution, you need to go back and substitute that in for your other equations. So this first one, they're both 5, right? So y is 5, x is negative 3. And then your second one, you can either leave it in standard form or you can substitute it into this one. It really doesn't matter. I'm just going to do it in the standard form because honestly, I think it's easier. So x is negative 3, y is 5, and then I'm just going to finish them. So that first one said y equals negative 4 times x minus 3. Because if you notice with the colors, all I did was I just substituted them in for x and y. And then the second one was x, negative 3, plus y, 5, equals 2. Okay? So then you guys would go through and solve them. So I'm just going to bring this one down here to make it easier. I don't know why I wrote them so close. This one's really easy, guys. If you have 3 negatives and 5 positives, think about it this way. 1, 2, 3, 3 negatives. Okay, 5 positives. 1, 2, 3, 4, 5. These cancel, and you're left with 2 positives. So that one totally works. We're good to go there. This next one, 5 equals negative 4 times negative 3 is a positive 12 minus 7. And then 12 minus 7 is 5. So 5 equals 5. Okay? So that's it, really. This is how you solve a system of equation by graphing. Hopefully this makes sense to you guys. And then I will make a couple more videos to help y'all out later when we talk about solving systems with different solutions by substitution and by elimination.